So in this video I will derive the equation for the AC current and AC voltage for single phase. So suppose you assume that there's a XY plane. This is from Y to Y dash and this is from X to X dash, and there is a field which is flowing in this direction. This is a electric or this is a magnetic field with the flux phi. So if you are having a coil such that is located along this axis, which is making angle theta here, and which is rotating at an angular speed of omega. Omega is angular speed in radians per second, and theta is equal to omega t. So this coil is rotating, and this will be symmetrical, and so what is seen is that if the flux phi is produced by a alternating source or time varying such that flux phi is equal to phi m cos omega t, then the flux linkage n phi will be is equal to n phi m cos omega t, while the n is the number of turns of this coil, which is 1 in this case, this specific case, and the EMF given by the Faraday's law of electromagnetic induction will be E is equal to minus d phi by dt, n d phi by dt, which is equal to E is equal to d by dt minus of n phi m cos omega t. So if you are differentiating it, you will get n phi m omega sine of omega t. This is the EMF which is induced, and this is in volts. So suppose when we are having a omega t that is equal to theta of 90 degree, that is the coil is in this position, it is in position parallel to the flux lines, no EMF will be induced in the coil because the flux linkage will be maximum but the EMF induced will be 0. So in that case EMF or the flux linkage will be 0 and the EMF induced or maximum EMF is induced. So the flux linkage in this case, when it will be parallel, will be 0, but the EMF induced will be maximum, and the EMF will be n phi m omega. So this is known as the E max EMF. So the equation of the EMF or the electric current induced in the coil, electric voltage induced in the coil, becomes E is equal to Em sine omega t. Now if you are considering a resistive load, considering that this coil is connected to a resistance of R, so current will be flowing which is I, and the current I is equal to V by R, so which is equal to I is equal to Im sine omega t, and Em divided by R is equal to my Im. So again, what you can see is that the frequency of the induced voltage uh, is given as 50 Hertz. If it is to be 50 Hertz, then 1 upon f is known as your time period. So this will be the rate at which the voltage will be alternating. So again, it is seen that uh, whatever my voltage is induced, this is v is equal to em sine omega t, is a alternating voltage, and it will have its maximum at 90 degree, and it will have its negative maximum at 270 degree, and the voltage will be 0 at 0 degree and at 360 degree respectively. If I am having the same way, my current will be varying somewhere like this. So this is my current. I is equal to Im sine omega t. So this is for the resistive load. So these are the basic equations of the current and the voltage, and if you are having a frequency is given by f is equal to Pn divided by 120 for usually for generators. So to have a frequency of 50 Hertz, you will need to choose your number of poles of your generator and the speed of the generator in such a way that it gives you a 50 Hertz frequency, or based on the speed it is possible to decide the poles and design it such that your frequency, and the frequency of the electricity in India is usually 50 Hertz, while in some of the foreign countries it's 60 Hertz. And the line to line voltage is usually 230 volt. Line to neutral voltage is 230 volts in India approximately. So the next what we will see is that the effect of the AC voltage on resistive load and resistive and inductive load. The Im value and the Em value used here are usually in RMS or root mean square values, so you'll have to take into consideration while you are solving the numericals.